Hi 3Cs, what we're going to start now is financial mathematics. Now most students enjoy this part of the course, okay, because we're learning all about money and how money works in the real world. Now before we actually start with the money section, we're going to have to do some thinking. And we're putting our thinking cap on, and the reason we're doing that is you can see I have a question here. It says to determine the percent of a number. And later on in this page I have some other skills that you probably know and maybe not, but we're just going to review them before we get started. Now to determine the percent of any number, what we have to do is we take the percent, we write it as a decimal. Now remember how we do that from our last unit even, meant that we would take the number, we would divide it by 100, and that would turn it into a decimal for us. Now some of you move the decimal place over 2 places, and that is great, but if you ever forget which way the decimal goes, always take the percent and divide it by 100. After we've done that, then we multiply by that number that we get. So let's look at an example. If I asked us to find 8% of 150, well, according to this, I'm supposed to take my 8% and change it into a decimal. So 8 divided by 100, and I end up with 0.08. Now in mathematics, you maybe remember, of means times. So we're going to multiply by 150. And we would take our calculator, which I do not have one with me, so I'm going to have to grab one. Here we go. Here's my little scientific one. So I'm going to go decimal 0.8 times 150 equals 12. Okay, so that's a really basic skill that you have to be able to do. You've been doing that since elementary school, so you should be pretty good at it by now. So you take the percent, divide by 100, then multiply by the number. Another important skill for this unit that we're going into has to do with vocabulary. And you're thinking, hey, this is a math class, I shouldn't have to talk about English. Well, guess what? That's not true. It's important for us to understand what certain words mean. Now, interest. Interest means different things on whether I'm investing money or if I'm borrowing money. But in each case, what interest really is they are paying you money for the use of money. So money, for me using your money, I'm going to pay you some money. Or if I borrow money to you, you're going to have to pay me some more money for me using or you using that money. So that's what interest really is. It's a fee that we all pay for the use of money. Now the next thing you also need to be able to do, and that has to do with the calendar. Okay, I couldn't find anything animated for calendar, so you'll just have to put up with that. Now when we're talking about money, financial part, we're usually always talking about something about 1 year. We're comparing it to 1 year time spans. So what I have here is 1 year equivalents. There's that word equals. So I'm just going to bring this up, and in case you have forgot, we need to know what is equivalent to 1 year. Well, there are 12 months in a year. There are how many weeks in a year? 52. And there are 365 days in a year. Now, this I will post in case we need that throughout this unit. There'll be quite a few things being posted around the classroom to help you with some of the vocabulary as well as some of the concepts. So we need to keep this in mind. So, in order to understand how money is going to work, we're going to look at an example. And today we're just going to be talking about simple interest. Right? So just simple interest. And you're thinking, well, what other kind of interest is there? Well, there's another thing called compound interest. Now, simple interest means that I'm going to pay for the use of your money, but I'm going to give you a check for it, or I'm going to give it to you so it's not being reinvested. So simple interest is money that you're getting when something hasn't been reinvested. And to look at this example, you notice there's a picture here, and this happens in some homes. This is Rachel, and when she was born, her grandparents deposited $1,000 into an account that earns 6% per year for 5 years. So if we look here, we can see that there are 5 candles. So this must be her 5th birthday. Now, every year on her birthday, she receives a check for the interest that she earned. Okay, so that's pretty good birthday present, I would think, every year. So that's the situation. She was born, her grandparents gave $1,000, which they put into an account that earns 6% interest every year for 5 years. At the end of each year, she receives a check for the interest on that $1,000. Now what we're going to do is we have 2 questions to try to figure out. We want to determine how much interest she earns after 1 year. We also then want to determine the total interest that she's accumulated, okay, or received at the end of 5 years. And to do that, we are going to look at a table so we can talk about this. Now, if you notice, we're starting with the different years here. So, amount in account. So, at the end of the first year, okay, so year 0 is the first year, if you want to look at it, times 0, her grandparents put in $1,000. At the end of that first year, how much interest did she earn at 6%? Well, so in other words, I want to take 6% of $1,000. So that means I'm going to change my 6% to decimal 0.6. And I'm going to multiply it by 1,000. Now, most of you maybe can do that in your head, but it's getting kind of late for me, so let's try that. So I'm going to clear my calculator, and I'm going to put in decimal 0.6 times 1,000. And you notice that she earned $60 in interest. So she has $60. So she would have received a check for $60. So the total interest accumulated, okay, first year, $60. Now, the second year, again, she still has $1,000, and when I take 6% of $1,000, I get another $60, which means now, in total interest that she's received, it's $120, because she received $60 at the end of the first year, and now another $60 at the end of the second. Now, You maybe notice that when I take the 6% again and multiply it by 1,000, I'm going to get $60 again. And when I do it here, I'm going to get $60. And I'm going to get $60 for the last year. So that part with simple interest does not change. It's always $60. Now, total interest accumulated each time, however, does change. So I have $60, 120. If I add another 60, I'm going to have $180. And if I have another $60, I am going to have $240. And last but not least, $300. So what that means in the total at the end of 5 years, Rachel has received $300. Now she still has the $1,000 that her grandparents gave her, okay? But the $300, the money was working for her. Okay, she didn't have to work for that $300. That was in interest. So that's not too bad. $1,000, $1,300. Now, maybe what I'm going to do, sorry, I shouldn't have turned the page there. If I go back to that table, because you guys know a lot about table of values now. We've done it in almost every single unit. What would happen if I subtracted these numbers each time? What number am I going to get? I'm going to get 60. And I'm going to get another 60. And I'm going to get 60. So first differences here ended up with 60. In other words, the same number each time. And you know what that means. It means that if I graphed this, because my first differences are the same, so my first differences are the same, so we know that that actually would be linear. So if we graphed it, it would be a straight line. Okay? Now, moving right on,